In this video, we're going to look at the number system. Now, we are all very familiar with the sketch that is on the screen that tells us about the different kinds of numbers that we have. In addition to the sketch, I want to use a number line that is going to help us to understand the number system. So on our number line, we have got positive numbers, the numbers 1, 2, 3, 4, 5, 6, continuing on. These are individual numbers. They are separated and they are not connected. So dot, 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 continue. These numbers that are 1, 2, 3 continuing, the numbers that you learn how to count when you are in preschool, are called natural numbers. So naturally, you start at 1, right? Our next, so that would be our inner circle over here. Actually, no, this should not be there. So our natural numbers. Natural numbers, the symbol is an N like that. Our second one is the one that's in the inner circle, which is called whole numbers. Now, whole numbers, the symbol is the N for natural numbers with a 0 at the bottom. And the reason for that is because your whole numbers consist of these numbers 1, 2, 3, 4, 5, dot, dot, to infinity. But it also includes the number 0. Although 0 is not a number, it includes the concept of 0. So again, we're talking about separate digits, separate numbers that are not connected with one another. These are whole numbers. Natural numbers plus 0 makes whole numbers. Our next concept is called integers. Now, integers has got the symbol Z. And integers consists of natural numbers 1, 2, 3, dot, 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 whole numbers 0, 1, 2, 3, and negative numbers, dot, dot, dot. So these numbers, again, are separate numbers. Let's do it on top. And they are not connected. They are separate from one another. So we've got natural numbers, whole numbers, which is 1, 2, 3 plus 0, and integers, which are positive, 0, and negative numbers. Now we have this concept of rational and irrational numbers. You need to know the difference between rational and irrational numbers. So let's do rational numbers in orange, and we'll do irrational numbers in red. Rational numbers have got the symbol Q. Rational numbers are numbers that are in between these whole numbers. So the numbers, if you take between 1 and 2, you can get a number between 1 and 2, right? You could get 1.5, 1 3/4, 1,5, 1,025. So there's a whole lot of different options in between. So for our rational numbers, we are looking at proper fractions. So a fraction is a number that has a numerator and a denominator. A proper fraction will be something like 1/2, where the numerator is smaller than the denominator. That is a rational number. You can have improper fractions, or you can have mixed numbers. Like, for example, if you had 3/2 is an improper fraction, or 1½ is an improper fraction. These are rational numbers. Another example is what we call a terminating decimal. Terminating means end, an ending decimal, a decimal that does not continue forever. For example, 0,25 ends right there. It's got 3 digits, 0, 2, and 5, and then it ends. It does not continue forever. And then we have what we call recurring decimals. So 0.25, for example, is equal to a quarter. If I was to write 1/3, a third, as a decimal, I would write 0.3333 recurring, or 0.3 recurring. It continues forever, 333333333. These are the 4 different kinds of numbers that are rational numbers. In addition to that, you also have integers, whole numbers, and natural numbers are rational numbers. Okay? Now, what are irrational numbers? Irrational numbers have got the symbol Q with an apostrophe. In other words, not rational. A not rational number, if we go through the list, we said that proper and improper fractions are both rational. Let's talk about decimals. If you have a non-terminating, meaning it does not end, and it is non-recurring, meaning it does not repeat, decimal. If you have a decimal that does not end and the numbers do not repeat in the same pattern, then it is irrational. For example, 1,2, hold on, you can't have 2 decimals. Okay, 1,2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 0, 2, 3. This would be a repetition, 4, 5, 6, 7. Because 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7. It repeats, right? So this is not because it's recurring, it is not irrational. But if you had something like 3,759,8, 2, 1, 5, 3, 4, 7, 6, 9, blah, 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 blah. There is no pattern in this decimal. Therefore, it is a non-recurring, non-terminating. It continues forever. So these are irrational numbers. In addition to this, you can have square roots of a number that is not a perfect square. Like, for example, square root of 5 is not a perfect square. It is irrational. The same applies for cube roots. The cube root of 7 is irrational. So if it's not a perfect square, not a perfect cube, it's going to give you an answer like this. And that is why it is irrational. Another number that is very specific is the number pi. Pi is an irrational number because it is a non-terminating, non-recurring decimal. So in other words, all 3 of these are all non-terminating, non-recurring decimals. Last concept that you need to know is what are real numbers. So a real number, let's change the color. A real number is everything. All of these together are real numbers. So when you are working with these, they will always be real numbers. There are non-real numbers. You don't need to worry about it. But for example, if you get an error message on your calculator, that will be a non-real number. It's called an imaginary number. So if I said 3/0 on your calculator, you will get an error because it's an imaginary number. Or if I said the square root of -9, you will get an error message. That is a imaginary number. So those are not real numbers. Excellent. Let's attempt this question. This question is asking us, is this number rational, irrational, or neither? So we said rational means, or let's do irrational. Irrational means it is non-terminating, it does not end. It is non-recurring, it does not repeat. It is a square root or a cube root of a number that is not a perfect square or perfect cube. So, or it is pi. So those are the four options. So let's see. A is 0.25. It ends there. It is terminating, so it is rational. We said rational symbol is Q. Okay, let's do this. We'll have a heading for rational, and we'll have irrational has got two R's. Hold on. Q not. Okay. So let's see where we're going to put everything. We're going to put A under rational. B, -0, -4. That is rational. It's an ending number. It's an integer. It's rational. Pi plus 8. Pi plus 8 is going to be irrational. C. The reason why is because of that pi being in there. The square root of 11. 11 is not a perfect square, so this is irrational. The square root of -11 is neither. So if it's neither, it means it is imaginary. So an imaginary number is going to imaginary number. E is imaginary because if I put that in my calculator, I get an error message. Square root of 9 is 3, so that one is rational. 2/3 is a proper fraction. It is rational. 5/0 gives me an error message. That is imaginary. Pi over pi. Trick question. Pi over pi cancels out, so that gives me 1. That makes it a rational number. 0.3232323232323232 recurring is rational. 0.6820045370518346 non-recurring is irrational. The cube root of -8 is rational. The cube root of -7 is irrational. Pi over 3 is irrational. The cube root, the square root of 4/9, that gives me 2/3, so that is rational. 2 times pi is going to be irrational. 0 times pi, any number multiplied by 0 is 0. So I'm going to make that rational. The fourth root of -16. Let's quickly just talk about this. If I do a square root or a fourth root or sixth root, I cannot have a minus sign here. This is not possible. It has to be positive because this is even. There must be an even number of signs here. So it must be 2, meaning a plus sign. If I have the square root of a negative number, square root, fourth root, or sixth root, this is an imaginary number. However, if I have the cube root of a negative number or the cube root of a positive number, both of these are possible and they could be rational or irrational, but they're both possible. This is imaginary. So right now I have the cube root of -7. Cube root can be negative, but 7 is going to make it an irrational number. So it's not imaginary, it's irrational. Pi over 3, I'm going to say that one is, oh, I've done that one already. Irrational. Oh, where am I now? Oh, I'm on R. Okay, so the fourth root of -16, because of the minus sign, it is imaginary. And then the square root of 4 plus 9 makes it the square root of 11, which is irrational. There we go. So S is over there. That is how we do this exercise. I hope that this video helped you. Please be sure to like and subscribe, and I'll see you in the next one. Bye-bye.